realization that there are relationships between the physical constants themselves which seem to be necessary for us to be here. One such coincidence is the fact that you need to have stars which are both convective and radiative in their outer envelopes. That's to say, the heat generated in the core can get to the surface by radiative processes or convective processes. That only happens around a critical mass. And that critical mass is in the mass range in which stars actually exist, only because of a remarkable tuning between the gravitational fine structure constant, which is this tiny value of 10 to the minus 40, and the electrical fine structure constant, which is called the fine structure constant, which is roughly 10 to the minus 2. It's 1 over 137. It turns out that the reason we have both these types of stars is only because of this remarkable tuning, that the gravitational fine structure constant is the 20th power of the electric fine structure constant.
And the key thing is what enables biomolecules exist. And there's two really important biomolecules. The one is DNA and RNA. The ones which are, in a sense, much more important are the proteins. And in fact, the proteins are the ones that actually do the work. The question is, if you shift the fine structure constant, DNA winds up on itself in a certain pattern. Will you destroy that ability to wind up and those matchings to take place? That's one kind of question.
The
fine structure constant.
Yeah, fine structure constant is?
Well, roughly, it's the strength of the electromagnetic force. Okay. And then the ratio of the electron to the proton mass is another one which comes in and affects these, because these affects the shapes of molecules. And then the second one is a huge amount of stuff which goes on in biology, the lock and key mechanism of biology, where molecules fit together and cause conformations to change and so on, that the laws of physics had the foreknowledge of biology written into it. And that's a rather strange kind of statement.